Checkpoint 1. Does the capacitance C of the capacitor increase, decrease, or remains the same when the charge Q on it is doubled and when the potential difference V across it is tripled? So in this checkpoint, we have to answer for these two questions. What will happen if the charge will be doubled, and what will happen if the potential difference across the capacitor will be tripled? So for that, we have to answer from these three options. What are the three options they give? The capacitance will be increased or decreased or remains the same. So for answering this checkpoint, we have to consider the main factors which affecting the capacitors of the capacitor. In theory, we studied there are four main factors which affects the capacitance of the capacitor. The first main factor is the shape and the size of the plate of the capacitor. And the second main factor is the cross-section area of the plates. And the third main factor is the distance between the two plates. The distance between the two plates. And the last point is the dielectric medium which we kept in between the plates. So here we have these four factors, and your capacitance of the capacitor entirely depend on these four factors only. It will not depend on the charge as well as the potential. After we read these 4 points, there is no information about the charge and the potential that will affect the capacitance of the capacitor. So actually here the answer for these two questions, or the capacitance of the capacitor, will remain the same. And in another way also we can give the answer for this question. Actually, we have three capacitors which we studied in the theory. The parallel plate capacitor, the formula for parallel plate capacitor, which is given by the equation C, which is equal to epsilon naught A over D. This is the formula for parallel plate capacitor. And then for the cylindrical capacitor, the formula is given by C, which is equal to 2 pi epsilon naught L over the natural log of R2 over R1. So here R2 is nothing but the outer radius and R1 is the inner radius. And the third main thing is the spherical capacitor, which is given by the rule C, which is equal to 4 pi epsilon naught R1 R2 over R2 minus R1. Now you can see these three formulas because we are using this formula for calculating the capacitance of the parallel plate capacitor, cylindrical capacitor, and spherical capacitor. And if you come across this formula, there is no information about the charge as well as the potential. So that means again it will be clearly proved the charge as well as the potential difference will not affect the capacitance of the capacitor. Only these four factors are responsible for the capacitance of the capacitor that will affect the capacitance of the capacitor. So here, based on this point, I can answer for the first question. If you double the charge, what will happen to the capacitance of the capacitor? It will remains the same. It will remain the same. Likewise, for the B part, if you triple the potential difference, again, it will not affect the capacitance of the capacitor. So the answer for the second part is also the capacitance of the capacitor remains the same. So this is the answer for the first checkpoint. That's it. Thank you.